I'm doing this integral by 4 methods. So this is a very good example for those who are taking basic calculus course. Now here, method 1. It's obviously that I'm using a formula to reduce the power for sine, which is equal to x times half 1 minus cosine 2x. Okay, so this gives me 2 integral, which is 1/2 x from 0 to pi dx, that is this one, and minus 1/2 from 0 to this x cosine 2x dx. Okay, this one is easy, 1/2 half x squared. Now for that one, I'm using by parts, right? This is 1/2, and x, this will be d sine 2x, right? Then I get 2. I have to balance to multiply by 1/2 again. Yeah. Okay, then see the first one is 1/4 pi square. Now for the second one is 1/4 u dv, right? So u v minus become plus v du. V is this, sine 2x, du is dx. Okay, this is 1/4 pi square. Sine 2 pi is 0. Sine 0 is 0, so this is gone. Now for that one, well, I don't need anything, right? And this is simply 1/2. 1/2 times this one is 8. And cosine 2x. Yeah, but negative. So 1/4 becomes a negative. Yeah, from 0 to 2 pi. Okay. That one is equal to 1/4 pi square minus 1/8. Cosine pi is a 1. Cosine 2 pi is a 1. Cosine 0 is a 1. Therefore, my result is pi squared over 4. Okay, that is the result for this integral by method 1. Now, method 2. Method 2, while I'm using the formula for the sine in complex numbers, this is equal to x 2I xi minus x negative xi square. Okay, this is a sine x by using a complex number. So this one is equal to how 2I squared is negative 4, and integral, this becomes e to the 2x pi I plus e to the negative 2xi minus 2 times x, right? Yeah, I don't forget x, dx. Okay, there's x here. Then for this 2, 1/4 becomes a positive 1/2, right? Positive 1/2 x dx. That taking care of this one. And minus 1/4 integral x e to 2xi plus e to the negative 2xi dx. Okay, the first one is 0 to pi. That is this one. For that one, how about that? Minus 1/4 0 to pi. This one becomes d 2xi minus 2 negative 2xi, right? Then I get 2i as a coefficient, then divided by 2i, right? Then it's okay. All right, good. This one is equal to 1/4 pi square. And this is minus 1/4. I can combine them together, right? This is x times d 2i 2x negative 2xi. Well, this is sine 2x, right? So this becomes a quarter pi squared minus 1/4. So this is x d sine 2x. Yeah, so I can use the by parts again. This is a quarter pi squared minus 1/4 uv, right? U times v minus v du. Integral v is this, du is dx. Okay, so this becomes a quarter pi square minus 1/4. This is 0, right? This is 0, yeah. This is a negative half cosine, so it becomes a positive half cosine 2x. Yeah, so this is a quarter pi square minus 1/8. This is the first one is 1, right? The second one is 1. So the result is a quarter pi square, which is the same as the second method, as of the first method. Okay, this is the second method. Now the third method. The third method I'm using substitution to start with. I'll let x be 1/2 pi minus t. So this becomes half pi minus t for x. Sine half pi minus t is cosine. So this becomes cosine squared t, right? Dx is a negative dt. Okay, good. When x is 0, this is a pi, half pi. When x is a 1 pi, this is a negative half pi. Now then I'm using negative to switch this. It becomes a negative half pi to positive half pi. So negative is gone, right? Becomes well, I don't jump, half pi cosine square t dt, right? That's the first one. The second one will be minus t cosine square t dt. Well, then this one is equal to 1/2 pi. Oh, this is an even function, right? So this is even function. I can do from 0 to half pi, then double, right? Double times 2 times 2. Cosine is half 1 plus cosine 2t. Now this function is order function. So in a symmetrical interval, it's a 0. Huh? I don't have to do it. So this one is equal to 1/2 pi. And 1/2 pi. The first integral is t. Right? First integral is t, yeah. And the second integral is half sine 2t, right? 0 to half pi. Yeah, it's good. This is a quarter pi square. Now plus 1/2. This is a sine pi. Sine pi is 0. Sine 0 is 0. So the result is a quarter pi squared. Same answer. Okay, this is method 3. Method 4. Method 4, I think this might be the best method for this particular integral. Substitution method. Let x be pi minus t. So the integral becomes pi minus t. Sine pi minus t is the same as sine t. So this becomes sine t squared dt from, no, dx is negative dt. Negative dt. Negative dt, huh? So this x is from pi to 0. Then I'm using negative to switch that one, right? So this becomes from 0 to pi. Now t and x just dummy variable, right? There's a no No difference. That's the first one. The second one is from 0 to pi. I change the dummy variable, this sine square x dx. So that is my I, This is my I, I in the beginning. Therefore, 2I is equal to pi and sine square x. Yeah, this method is good, shorter. So this is 1. And 1 minus cosine 2x dx. So this one is equal to the first one is there. The second one, this one's this. Second one is sine, right? Half sine 2x. Yeah. Okay, so this integral is this. Yes, correct. So this one is equal to half pi square minus 1/2. This is equal to 0 minus 0. So this one equal to half pi square. This is 2i, right? 2i is this. 2i is this. So I is equal to, yeah, same answer. Yeah, this is the best method for this particular integral. Now, okay, this example, I believe is very good for those who are taking the basic calculus course, because you can really maneuvering different kind of methods in the integration. So you can definitely improving the techniques of integration. Thank you for your watching.